katılımcıları görmek yerine konuşmayı büyük görmek isterseniz orada layout seçeneklerinden öyle bir seçim yapılabiliyor. Şimdi bir de etkinliğimizin dili Türkçe olacak. Sadece Christophe Weisse'in sunumu İngilizce olacak. Saat 10'u 5 geçiyor. Programa da sadık kalmak adına şimdi ben sözü Optofil'den Furkan Eren'e Zemax ürün tanıtımı sunumu için veriyorum.
Merhabalar, ben Optofil firmasından Furkan Eren. Bugün sizlere Zemax ürünleri ve Zemax'ın kampanyalı programlarından kısaca bahsedeceğim. Zemax'ın 4 temel programı bulunmaktadır. Bunlar Optic Studio, Optic Builder, Optic Weaver ve yeni çıkan Star modülü. Optik tasarımlarınız için ihtiyacınız olan her şeyi Optic Studio programı üzerinden gerçekleştirebilirsiniz. Optic Builder programı ile Optic Studio üzerinde yapmış olduğunuz optik tasarımlarınızı ekstra bir efor sarf etmeden rahat bir şekilde CAD ortamına aktarabilirsiniz. Optic Builder programı şu an sadece Creo CAD programı ile uyumlu olarak çalışabilmektedir. Optic Weaver programı ise Optic Studio üzerinde yapmış olduğunuz optik tasarımların üretim sürecine rahat bir şekilde aktarılmasını sağlayan yardımcı bir programdır. Burada optik tasarım mühendisleri ile üretim mühendisleri arasında bir köprü görevi gören bir programdır. Star modülü, yeni çıkan Star modülünün detaylı bilgisi ise konuşmacılardan Christophe tarafından size detaylı bir şekilde aktarılacaktır. Optic Studio lisansı 3 farklı lisans seçeneğiyle kullanıcılara sunulmaktadır. Bunlar standart, professional ve premium olmak üzere. Standart lisans tipi ile sequential mod tasarımlarınızı yapabilirken professional ve premium ile non-sequential tasarımlarınızı da gerçekleştirebilirsiniz. Ayrıca premium lisansın CAD entegrasyonu sayesinde ürünleştirme kısmında, optik tasarımlarınızı ürünleştirme kısmında büyük bir kolaylık sağlamaktadır. Bu 3 lisans tipi sadece tek bir kullanıcıya ve tek bir bilgisayara tanımlanmaktadır. Bu sebeple Zemax, Professional ve Premium lisanslar için Network lisans seçenekleri de sunmaktadır. Bu Network lisans seçenekleri sayesinde sadece tek bir kullanıcı online olmak koşuluyla birden fazla bilgisayara istediğiniz kadar bu lisansları tanımlayabilmektesiniz. Bir de ek bir bilgi olarak 2021 yılı itibariyle Zemax kalıcı lisans satışını durdurmuştur ve sadece abonelik tipi lisans satış seçenekleri sunulmaktadır. Bunlar 1 aylık, 6 aylık ve 1 yıllık olmak üzere çeşitli abonelik tipleriyle sunulmaktadır. Bu kısımda size Zemax'ın her seviyeden kullanıcı için hazırlamış olduğu kampanyalı programlardan bahsedeceğim. İlk olarak Global Akademi programına bakacak olursak eğer, bu programın amacı öğrenciler ve eğitimcilerin optik alanda kendilerini geliştirebilmeleri için hazırlanmış bir programdır. Bu program ile eğitimcilere ve öğrencilere ücretsiz bir şekilde OpticStudio Premium lisansı sunulmaktadır. Bu programa katılım için eğitimcinin üniversitede optik tasarım alanında bir ders açması ve bu açtığı dersle Zemax'a başvurması gerekiyor. Bu başvurduğu ders kapsamında Zemax öğrencilere ve eğitimcilere ücretsiz bir şekilde Optic Studio'nun en üst paketi olan Premium lisansını sunmaktadır. Bir diğer programımız ise Smart Araştırma Programı. Bu programın amacı ise akademik araştırma laboratuvarlarının en son teknolojilere cazip bir fiyatla erişmesini sağlamaktır. Bu program kapsamında araştırmacılara 3 yıllık Optic Studio Premium ve Optic Builder aboneliği verilmektedir. Bu programda ticari bir ürün geliştirilemez. Bu programlar sadece akademik çalışmalarda kullanılabilir. Burada normal lisans fiyatlarına göre çok daha cazip fiyatlarla araştırmacılara özel bir fiyat sunulmaktadır. Zemax Danışman Ortak Programı. Bu programın hedefi ise optik tasarım hizmeti veren firmalardır. Bu firmalara özel olarak çok cazip fiyatlarla firmalara 1 yıllık Optic Studio Premium ve OpticSbuilder aboneliği verilmektedir. Bu programa katılım için firmanın en fazla 5 çalışandan oluşması gerekiyor. Zemax, optik tasarım veren firmalar ile olan ilişkiye çok önem vermektedir. Bu sebeple bu programa katılan firmaları kendi resmi web sayfasında partner olarak göstermektedir. Bu ilişkiden dolayı firmalar hem yurt içi pazardan hem de yurt dışı pazardan müşteri edinebilmektedir. Zemax'ın son bu seneye özel çıkartmış olduğu bir program bulunmaktadır. Bu da Optic Studio Trading programı. Bu programın amacı ise süresi dolmuş veya dolmak üzere olan OpticStudio kalıcı lisansları en güncel OpticStudio abonelik lisansına çevirmeyi sağlıyor. Bu programa katılabilmek için elinizde süresi dolmuş veya dolmak üzere olan OpticStudio kalıcı lisanslarınızı Zemax'a teslim ediyorsunuz. Zemax ise bunun karşılığında size çok cazip bir fiyatla 1 yıllık abonelik lisansı sunuyor. Burada önemli olan kural, bu abonelik lisansınızı her sene güncellemeniz gerekmektedir. Çünkü burada size normal lisans fiyatının yaklaşık yarı fiyatına bir abonelik lisansı sunulmaktadır. Ve bunun sayesinde siz bu kalıcı lisansınız yerine abonelik lisansı ömür boyu indirimli bir fiyat üzerinden devam ettirebilmektesinizdir. Bu sayede en güncel OpticStudio yazılımına her sene en iyi fiyat garantisiyle ulaşabiliyorsunuz. Burada size bahsetmek istediğim kısaca lisanslar ve programlar bu şekildeydi. Detaylı bilgi için mail adresleri üzerinden bize ulaşabilirsiniz. Beni dinlediğiniz için teşekkür ederim. Sözü tekrardan Alper Bey'e bırakıyorum.
Teşekkürler Furkan. 3 dakikamız var diğer konuşma için. O süreyi bekleyelim isterseniz o konuşmaya başlamadan. Herhangi bir soru, cevap, yorum kısmında veya mikrofonla lütfen sorabilirsiniz. Çekinmeyin. Herkese günaydın. Günaydın demek isteyen de lütfen çekinmesin. So, Christophe, we will start in 2-3 minutes. So you should be able to share your screen.
Yes, sure. Let me do that right now. Yep.
It's coming.
You should be able to see my screen now.
Yes, it's visible. Great. So let's wait a few minutes and then
Sure.
we can start. Okay, so this part will be in English. Christophe Weisse is a solution engineer of Zemax, and Christophe will talk about the STAR module, which is a newly introduced module to OpticStudio this year. Okay, Christophe, the floor is yours. Thank you very much.
Thank you. Thank you, Alper, and good morning, everyone. Nice to virtually meet you. Well, this presentation today is about a new module we have added actually in May this year to OpticStudio. It's called the Star module. So just, yeah, as a reminder, maybe, so OpticStudio is really a tool that is key to design optical systems, a wide range of optical systems. So it has a number of benefits, an intuitive interface, many different analysis tools. You can optimize your system to any possible target. And then you can also tolerance your system and assess the real life optical performances of your system and all, well, any other manufacturability quantities or qualities you need to check. OpticStudio is also very easy to customize and to connect with our advanced programming interface or API. Speaking of connection, so this has been a goal for Zemax to not only provide you with the best possible optical design tools, but also to ease your workflow, to facilitate your work with other types of design. So mechanical design, we have introduced last year a CAD add-on called Optics Builder. And this year we have launched a new module, so the Star module, that integrates into OpticStudio and that facilitates the workflow between the FEA tool and OpticStudio. Right. So Star module, well, the name is quite explicit. So STAR stands for Structural Thermal Analysis and Results. And this module enables you to load, visualize, and fit the data that has been produced by finite element analysis simulations inside OpticStudio, update your OpticStudio model, and analyze the effects on the optical performances of your system. So for those who are not very familiar with finite element analysis simulation, so this is really the kind of tool that you need to see how your optomechanical system reacts when placed in any kind of challenging environment, like very hot or very cold environments, and also when the system is submitted to shock or vibrations. But it is also very important in case of very high power beams, like high power lasers, for instance, where the optical beam itself is producing heat into your system, and this heat has effects on the optical quality of your system. So it's very important for many different applications to really double check what is the effect of those side effects, so to speak. So we have added a number of new features to our user interface, so directly inside OpticStudio. We have also added the exact same functionalities in our programming interface as well, so that it is very easy for you to automate and customize your workflow around OpticStudio and your finite element analysis tool. So if I use the high power laser example, it shows you how our different tools and modules can integrate into a possible workflow and really facilitate your work. So, for instance, when you want to design such a system, you would start using OpticStudio and the sequential mode, which is the mode that is the most appropriate to design any kind of imaging system. So you can design the optical system and assess the nominal performance of your laser system. Then you can use Optics Builder to facilitate the workflow between OpticStudio and your CAD package, so Creo at the moment. And once that you have added and designed all the mechanical parts around your optical system, using Optics Builder, it is also then very easy to go back to OpticStudio non-sequential mode and compute, if needed, the absorbed power inside your system, because when you have a very high power laser, for instance, then the beam itself is heating, well, those optical elements due to absorbed flux. And why do we need to do that? Because those are then input parameters for your finite element analysis tool. So you need to feed that tool with not only the geometry of all the optical elements and the mechanical elements, but also some important parameters about the load that is applied to your optomechanical system. And you can also test various scenarios and so on. As you can see, maybe I don't know the quality of the screen sharing here, but the finite element analysis tool has its own kind of meshing here. So this is also why it's not always easy to use the results from this simulation here to easily update your OpticStudio initial model. And this is where the star module comes in very handy and is very helpful to make it easy and accurate for you. All right. So when we developed this star module, we have three main design principles in mind as goals. Well, first of the goal is, of course, accuracy, because, well, this is what you are looking at. Basically, this is what you want. Ease of use. This is extremely important, and this is really not as easy as it seems. So it was a very important part of our work here. And platform agnostic. So this means basically that we designed the star module to be able to connect virtually with any FEA tool out there. So if I go back one slide, you can see here that I named a few FEA solvers there. So ANSYS, Nastran, Abacus. There are also a number of other tools. So COMSOL, you have also a solver in some CAD tools such as Creo, number of FEA tools out there, and our goal was to be able to connect with any of these. I will explain later how we achieved that. Also quite important to notice, and this also explains how we approach the development of new features or new module. We usually partner with customers that help us test like alpha or beta versions of our new capabilities. So for the star module, we have actually stretched that to a larger number of users. So we partnered with 25 plus users that has different use cases, from space optics, high-powered lasers, photolithography, and so on. So it was tested and validated by those users that are already dealing on a regular basis with this kind of structural deformation and thermal load. This module has been launched in May this year with the 21.2 release of our tools. So it is still a brand new module, but already heavily tested beforehand. And as all our tools, so as OpticStudio, as Optics Builder, as Optics Viewer, it will be updated every 4 months, so 3 times a year, to provide you with additional functionalities. So how does it work? When you get results from your FEA tool, in principle, what you need to do is, using this interface here, load the different files that represent either the structural data, so the surface deformations, or the thermal profile of an element, and then you can assign a specific data set to a specific surface. And you have this 3D visualization tool that provides you with a live feedback of how the FEA dataset is looking like and where it is positioned into your system. And this is already a kind of key feature, because for many different reasons, there are a number of reasons why the dataset that you are importing might not fit right ahead with the initial definition of your optical system. I got actually myself trapped the other day. I was trying to use FEA datasets. I loaded them, and all the points were at the center of the optical element. And then I realized that I had a mismatch. I had different units in the FEA tool I was using and in OpticStudio. So in OpticStudio, I was using millimeters, and in the FEA tool, I was using meters. So if you don't have a visual feedback, it might be hard for you to actually see that, and then you apply the data to your system and you have weird results and you don't understand why. So this is actually very important to have that kind of feedback. So I was able to quickly change the units so that they align to millimeters and move forward. Same here. The best practice is to keep track of the coordinate system between OpticStudio, your CAD package, your FEA tool, but for some reason, sometimes it might get lost or it might be altered during the different steps of that workflow. So we have tools here to deal with that and to convert the coordinate system from global to local, or even to use user-defined transformations, so translation or rotation, to properly place the FEA data into your system. And so once that it is done, you just click on OK. The star module is doing its thing. I will go into more details later, but basically you select those files, you hit OK, and OpticStudio is applying all the effects to your optical system. And then basically you can use any OpticStudio tool, so any analysis, any tolerance, any, I don't know, any feature really can be used with the additional effects of the structural deformations and the thermal load. If we have time, I will quickly show you how this works in OpticStudio, but you can already see here, or guess maybe, what is happening. So every analysis window is updated with the results, but the structure of the file itself is not changed. It is kept as originally defined. Actually, the deformations and the thermal load of your system are used to add additional layers to your initial system definition. So pretty much similarly to what happens with your photo editing tool, you can also activate or unactivate those layers directly inside OpticStudio. So you can decouple the structural and thermal impacts on your system, and you can also do that surface by surface or element by element to analyze very accurately what's happening in your system, and have a very good understanding of what's happening in there, what is your worst offender, and so on. So maybe some additional details here about different aspects. So in principle, as you saw here, it's rather easy. You basically select your FEA dataset, hit OK, and use OpticStudio to see the effects. So really super easy. If we want to dig into more details, first we need to start with the kind of data that the STAR module is using, and to make the STAR module able to connect with virtually any FEA tool out there, we chose to have a very simple input data structure required. So we are actually using a text file with very simple data formatting. So for the structural deformations, XYZ position, so the nodes, so to speak, and the displacement along each axis. And similarly for the temperature, XYZ position, and the temperature. So almost all FEA tools, I say almost because I don't know all of them, but all the well-known FEA tools, FEA solvers out there have the ability to export the results to to text files. Some to that exact format, some others to similar formats, but since there are text files, it's quite easy to post-process and to format to that particular format. So just to make it crystal clear, so we are using surface data to model the structural deformation, and volume data to actually use the temperature information in each point to create a gradient index material inside your system. So taking into account the material properties that describe how the index changes versus the temperature. So very important aspect as well, when you import FEA data, like raw unprocessed FEA data, it is not that easy to use by OpticStudio for many different reasons. The type of the mesh that is used by the FEA data is quite different from what we are using in OpticStudio, and sometimes you need to use a rather high number of points to make the FEA simulation accurate. So what we have seen during our tests is that very often the FEA datasets have somewhere between 10,000 and 100,000 points, so quite a lot. We actually had a meeting yesterday with an OpticStudio user that told us that they are trying to use FEA datasets with billions of points, so even worse. So at that point, there's a need to make a fit to keep the simulation time reasonable. The traditional approach here is to use Zernike polynomials, but during the development of the STAR module, what we have seen is that this is not the optimum method, especially because if you want to reach the desired precision, you need to use a very high number of Zernike coefficients. So we came with a different approach using a non-uniform sampling of the data, so that we can adapt the step of the grid we are using to the shape and the slope of the deformations locally. So we are using a 2D non-uniform grid to fit the data for the surface deformations, and a 3D non-uniform grid for the thermal load and the temperature profiles. Of course, we have a tool to assess the quality of the fit so that you can compare the fit that has been made automatically by the star module and the initial FEA data. You can also change the fit parameters if for some reason this doesn't seem accurate enough for you, but you have the ability to review and control how that fit is done. Yeah, so I already explained that because I tend to talk quite a lot. So you can, since all those effects are dealt with using layers, you can turn those layers on and off, so you can activate or deactivate the effects surface by surface or element by element, or you also have shortcuts to do that as a whole for all the structural effects and all the thermal effects. We have also specific tools to provide you with additional insights about your system. So you have system viewers that can show you the deformation and how they are located into your system. Index maps as well, so that you can check what is happening for your materials. 2D deformation plots if you want to decouple what is happening along each axis. And we have also added options to existing tools inside OpticStudio, such as the surface sag map and the Wavefront Map. You are now able to remove the original shape to display only the difference between, let's say, the two versions of your system, so with and without the structural deformations, because otherwise it's not that easy to see the difference here. But when you actually subtract the original shape to the altered shape, then you can see that there is indeed quite some difference, and that it is actually not linear. It's a kind of wavy here, so likely to have an important impact on your system's performances. And same here for the Wavefront Map as well. Do you have any questions, or do you wish me to show you how it works directly in OpticStudio?
I think so. You like the attendees can raise hand or write in chat. Maybe I have a short question, Christophe. Is it
Yes.
okay?
Yeah, sure, of course.
Is this procedure done in an iterative manner, like one cycle and then second cycle, third, or just one cycle? You know what I mean? Like we get the structural thermal deformation data from FEA, we'll put it in OpticStudio, get the new analysis results, right? And then can we give this back to the FEA and obtain an updated, structural thermal analysis and feed it back one more time?
Yes.
Maybe
I see what you mean. So if I use this slide again, thanks Alper for the question. This is actually a rather important one. This is just an illustration of a potential workflow, right? So especially when you import FEA results into OpticStudio using the star module, you get a new, let's say, version of your system. then you can use any OpticStudio tool actually to modify the parameters of your initial system, because if you see, for instance, that the impact of the thermal and structural data on your optical output is too large, then you might want to change some parameters, like modify some material, or even use our optimization features to re-optimize your system, and so on. So strictly speaking, when you do that, you change the initial definition of your system, right? So you need to reconsider and potentially update the mechanical parts that are around your optical system if there is a large change of definition of your system, and well, do another cycle again, right? So this is where actually it is very, very useful to have the programming interface, because well, most of the popular, let's say, FEA tools out there also have a programming interface, so you can actually embed OpticStudio and this FEA tool into a larger simulation chain. So this is where it is important to, before you dive into the simulation itself, maybe you really think about what is the best workflow you can put in place, and how you will interact also with your colleagues from the mechanical and structural department. And this is also why basically we decided to add other tools to facilitate the communication between OpticStudio and CAD environments with Optics Builder, and the star module here also between FEA tools and OpticStudio.
Thank you. And I think we have another question from Onur Ferhanoğlu.
I have a comment actually.
Okay. Yes.
I'm not sure if you maybe mentioned this, but we all have heard about the Hubble telescope, right? So in its first installation, there was an, not error, but like a flatness in its large concave mirror, like it was 2-point-something meters concave mirror. And they had to correct for that. And since a lot of budget was already spent on the telescope itself to the space, they sent a co-star module to correct the optics. So here you're using the name star. So that's like a very nice coincidence, if you ask me, because you have things don't go as planned, like heat effects, and then you kind of have the, you know, capability to correct for that. So it's a nice coincidence to me that this is called star for different reason.
Well, thanks for sharing that. I didn't make the connection actually, so yeah, it makes me smile as well. But it's actually a nice example that illustrates how important it is to properly simulate how your optomechanical system will behave in the exact conditions where it will be used. And well, for space optics and especially, well, any kind of embedded system on the satellites and so on, it is very important to make sure that the system is very robust because of all the vibrations, the temperature variation that can occur, because yeah, it can be extremely cold, it can be pretty hot as well. So yeah, you really need to assess all those parameters before you actually, well, launch your satellite, because otherwise the cost of having to deal with the situation up there is way larger than spending some time on the simulation. And so actually it's further than simple simulation. It's really virtual prototyping, taking into account, well, all the exact environment parameters.
Okay, I think we don't have any further questions.
Yeah, so let me quickly open OpticStudio and show you how this works in OpticStudio. So we have a new star module here in the interface with all the specific tools. Of course, you always have access to all the other tools. So this is a beam steering system, rather simple example just to make it quick to demo, understand, and use basically. So this is a quite nice example though, because there are different types of surfaces, so standard surfaces, A-spheres, yeah, and we also have a lot of coordinate bricks. So tilted faces, tilted mirrors, and so on. So a situation where if you don't have the star module, it is really not that easy to use the FEA results to update your optic to update your optical design file. So first step would be to load the FEA data. So you can simply select a set of files directly. So all the structural files right there, and you can assign a data set to a particular surface. So you can see live that it is showing the shape of the FEA data and where it is positioned. So if I consider the mirror, so here everything is going smoothly because we kept track of the global coordinate system reference along the process. But if for some reason we would have lost track or changed definition, I will do that on purpose now. If you select the wrong option, you will directly see that the data set is not properly positioned in space, so in your system, and it won't produce valid results, basically. So with this visualization tool, you have the option to directly see where the data is applied and, roughly speaking, how it looks like. And you can do that for all the surfaces, of course. Let me do that. And so this is surface information for the deformations, and you can do the exact same process for the thermal load right there. And so now when you assign a data set to your system, you can see that it is actually a volume, right? And so you can do that for all the other elements, wedge 1, wedge 2. And when you click OK, well, the star module will basically do everything for you. So fitting the data to have an efficient model of your surface and applying the effects onto your system. So as you see, no change in the editor, though when you use any analysis tool, so I will simply use the spot diagram because it is a quite easy tool to use and to interpret. Let me make the density a bit higher maybe so that you can see it more easily. So now you have the results that is taking into account both the structural and thermal data to compute what is the let's say the updated performance of your system. So this is a spot size in angle space, so units are in milliradians. So this is actually showing that the beam is not fully collimated anymore. So if I remove, let's say, the or if I unactivate, to to be more accurate here, you can unactivate all the thermal data, and the spot size is updated, so it looks bigger, but the scale has changed, so it's actually smaller. If I hide the structural data as well, then yeah, you will be back to the nominal state of your system with a perfectly collimated beam and a zero angle of divergence, basically. So you can reactivate, let's say, the structural data or the thermal data for all the elements, or if you open here this structural summary window, you can also activate or deactivate some data sets. So if you want to see what is the impact of just this lens here, so the first wedge, you can see that, well, you can read the value right there. And you can do the same for the thermal data if you want to see the combination for that particular lens here of both the structural and the thermal data. You just need to click that box and the results will be updated, taking into account both effects. Right, so this type of feature and being able to easily activate or deactivate specific data sets is really very, very helpful, and we have very good feedbacks from users, because this is really something they didn't have before, and helping them to speed up their analysis time by a quite important factor. We have a few minutes left. I don't know if you have any additional questions about the STAR module, how it integrates with the workflow.
Do we have any questions from the audience? Yes, Onur Hocam.
Okay, again myself. So these optical elements normally are positioned in a housing, like this.
Yes.
So can we, I mean, for instance, a heat effect, a temperature load on the housing, can we simulate that? Because that would maybe decenter or tilt the optical components.
Yes, so important question indeed. So if I go back to this presentation really quickly, when you make the FEA simulation, so the structural and thermal simulation, you need indeed to take into account also the mechanical parts, right? So that this simulation is accurate, and you need to define all the material properties, thermal load, etc. And the FEA tool will take all those information into account to compute how the whole optomechanical system will be modified. So sometimes the surfaces are deformed, but in some other cases, as you explained, the whole shape of the structure may change. The easiest, or at least the easiest to understand modification would be an elongation of the housing due to heating, simply because the metal expands. But there could be some other effects. So indeed, lens displacements or tilts, and this is actually taken into account directly by the FEA tool. So the results that we get when you are loading these structural files here is often actually a combination of a displacement and an actual deformation. So the displacement is often called a rigid body motion, and then on top of that rigid body motion, so the displacement of the whole element, so to speak, and on top of that you have a deformation because of the stress that is applied to your lenses. Actually, you can see how both of those effects are combined when you open the fit assessment tool here. well, not only you can check, maybe I can use another surface right there. You can check what is the difference between the raw FEA data, so data as provided by the FEA tool, and the fitted model that the star module has created. So you can see the scale is really small, but you can also see rigid body motion values, because actually we give you the choice of looking at the FEA file as a combination of both rigid body motion and deformation, or to look at those a bit separately, should I say. So when you fit, by default, you are removing the rigid body motion before you fit the data, simply because then the chances are higher that the fit is more accurate. But you can choose also to not remove the rigid body motion. And yeah, so oops, sorry about that. If you do not remove the rigid body motion, then apply. Oh, it's not updating. Sorry about that. You can see that in the structural data window, though. Interesting. Why is it? Well, you can see that as well in the structural data summary here. No, not what I wanted to do. Sorry, right there. Let me make that window. I cannot. So you can display the rigid body motion values, right? And so if you choose to do not remove, okay. Should be all zeros right now. Oh, of course, I selected it for another surface. This is why it was not working. So you can see that for surface 12, I chose not to compute the rigid body motion, so to use the FEA dataset as is. So we give you the option basically to decouple both effects or to combine them. I hope my answer was clear enough, because I got a bit confused because I didn't apply the option to the proper surface, and I wasn't able to see the results afterwards. Sorry about that.
So, other questions? Any other questions from the audience? Okay, in that case, Christophe, thank you very much for your very insightful presentation.
Thank you.
On behalf of all the attendees, we couldn't simulate this in a virtual manner. Next time, we have to find a solution for the applause. Okay, so now it's time for a 15 minutes break. Let me switch to Turkish now.
All right.
Okay, thank you very much. Şimdi 15 dakika ara veriyoruz programımıza göre. Saat 11.15'te Barış Tanyeli'nin konuşmasıyla devam edeceğiz. 15 dakika sonra görüşmek üzere. Ben toplantıyı böyle açık bırakacağım. Görüşmek üzere.